What up? I'm Austin Proctor, and this is my Lab 5 at-home video lab report of the motion of falling objects. The objective today is to evaluate the motion of two different objects, one that has a considerable drag force and one that doesn't, and relate it to Newton's second law. And the two objects that we're using are a plastic Coke bottle, 24 ounces, filled with water, and that's going to be our object without a drag. And then the object with a drag is going to be a little green army man with a parachute, like we all used to play with. We'll start out the video with the motion of the bottle and the model of the object without drag, and then we'll go into the one with drag. To start out, we have the tracker file of the bottle, and you see I have a coordinate system set up. This is the negative axis that goes down. I've set a calibration stick on the bottle, which is 25.4 centimeters, and as you can see, he drops the bottle and there it goes. I think I measured this one in 30 frames. That's correct, 30 frames. And then I'll show you the, let's see, here is the code and the Python model for it, and we will run the Python, and as you see we have the same thing. Okay, the graphs for these are right here. The falling object, as you can see, they are pretty much the same. There might be a little bit of a difference just based on simple things like maybe slight wind resistance or something like that, but as you can see, the graphs do look pretty much identical. Let's see here, and now we'll move into the Army Man. We'll start out with the tracker, and same thing. I've set the coordinate system so that this is the negative axis. The calibration stick is measured at my friend right here. He is 6 feet tall exactly, so he says, and so that measures to be 1.828 meters. And as you can see, we drop it. Because of wind, it did move a little bit, as you can see, away from the axis, but that shouldn't have much effect on the actual on this part of what we're measuring, I guess you could say. The wind might play a little bit of part, and we'll go into that in just a second, but on the actual motion it should not be that big of a thing. And here we have the motion on the model, and we'll play it, and there's that. Okay, as you can see on the two graphs, this is the model on tracker, and then this is the graph from the model. The graphs do not look alike. We think because there's a considerable, or the drag force with the tracker, with the Army Man, is greater than the model, it seems like, and plus there are other things that could come into it. Since the little Army Man is so lightweight, the wind resistance does have a pretty big impact on that, and can sway it from left to right and really make it go any which way. So that did have an effect on it. And then, what does it mean? The drag model, or both models, represent Newton's second law, and it applies in both of these cases, and both models do go to a terminal velocity. And then the what if question was, what if the object was thrown downward initially, which means that instead of initial velocity starting at 0, there would have been an initial velocity, but both objects would still reach terminal velocity. So that's what we have for that. And in conclusion, this is what Greco looked like at the age of 2. Thank you for watching.